Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Find the prefix common array of two arrays. Leetcode 2657. In this problem, we are given zero index integer permutations a and b of length n. A sequence of n integers is called permutation if it contains all integers from 1 to n exactly once. For example, here n is equal to 4 and all the elements in a and b are in range 1 to 4. A prefix common array of a and b is an array C such that ith index in C stores the count of numbers that are present at or before the index I in both A and B. And in the end, we should return the prefix common array of both A and B. Then in example 1, for the given input arrays, at index 0, we see that there is no common element. So our count for index 0 is 0. Then at index 1, there are two common elements between A and B, that is 1 and 3. So our count at index 1 is 2. Then at index 2, A and B have three common elements, that is 1, 2 and 3. So our count at index 3 becomes 3. And finally at index 3, A and B have four common elements, that is 1, 2, 3 and 4. So our count at index 4 becomes 4 and our answer will be 0, 2, 3, 4. Now in terms of solution, when we hear prefix, we think of prefix tree or trie, but this problem is actually simpler. Let's explore this through multiple approaches. The naive approach to solve this problem can be that for each index I, we count the number of elements that are present in both arrays A and B from the start up to that index I. And for that, we will run the loop on array A using say iterator j from 0 to I and on array B using the iterator k again from 0 to I. Now for each element in the prefix of A up to I, we have to check if it is also present in prefix of B up to I, and once we count such common elements, we will set the value at the ith index. But the time complexity of this approach is O of n cube because of these three nested loops. And if you are interested in the solution, please check out the code link in the description below. And now the question is, how can we do better than naive approach? And the answer is, since we repeatedly check if elements in A are present in B up to a given index, we can leverage sets to reduce the time complexity from O of n to O of 1. So we can create two sets to store elements from A and B and keep track of elements encountered so far. And then for each index I, we add the elements in array A and B at ith index to the respective sets. And the intersection of these two sets will give us the common elements, and the count or size of this intersection will give us number of common elements at ith index. And now the time complexity reduces to O of n square because of two nested loops. So outer loop runs from 0 to n minus 1 and the intersection of two sets will take O of n time because we have to go through each elements of set A and see if it is present in set B or not. So because of this nested nature, the time complexity here is O of n square. And in terms of space complexity, the auxiliary space complexity will be O of n for storing the elements in the set. And in any case, we have to store and return the answer array. Now let's see this in action. First we start with index 0. Here A has 1 and B has 3. So we will add 1 to set A and 3 to set B and find the intersection between them. And as there are no common elements between the sets, we will set answer for 0th index as 0. Then we come to index 1 where we have 3 in array A and 1 in array B. So we will add 3 to set A and 1 to set B and now do the intersection between the two sets. This time there are two common elements. So answer for index 1 is 2. Then we come to index 2 and both the elements are 2 in array A and B. We add them to the respective sets and do the intersection between the sets and the answer is 3 this time. And finally at the last index, the element is 4 in both the arrays. So we will add 4 to set A and B and do the intersection between the sets. And now there are 4 intersecting elements. And finally our array becomes 0, 2, 3, 4, which will be our answer. And again, if you are interested in the code, please check out the code link in the description below. And now the question is, can we do better? And the answer is again yes. For that, let's make some important observations. We have two arrays and we need to find the common count up to a particular index, and that will be our answer for that index. Both A and B are permutations, meaning all integers from 1 to n are present exactly once. So that means there are no duplicates. And as we scan from 0 to I, when we count an element in one array, say element 1 in array A, then its count becomes 1, but it is not counted yet in array B. But as we move along, we encounter the same element in the other array, say at index 1, then the count becomes 2. And this is the maximum count for any element because there are no duplicates in either array. Therefore, instead of using a set, we can use a frequency map to track the occurrences. So now when we loop using the iterator I from 0 to n minus 1, we can count the frequency of each element encountered so far and add it to the frequency map. And if the frequency of the element becomes 2, it indicates a common element. So we increment our answer by 1 and repeat the same steps for the element at ith index in B. And in the end, the updated answer will be stored in the result array at ith index. And since the range of the elements is 1 to n, we can also use a frequency array where ith index will store the frequency of ith element. So for example, for number 1, we can store the frequency at index 1. For number 3, we can store the frequency at index 3 and so on. So we will be creating a frequency array of size n plus 1 because our arrays are 0 index but the elements start from 1. So we start with index 0 and 0th element in A is 1 and B is 3. And the frequency at index 1 is 0 here. So we will increment the frequency by 1. Similarly, for number 3 also frequency will become 1. So none of the frequencies became 2. So that means we couldn't find these two as a common element yet. So our common count is 0 and that will be our answer for 0th index. Then we come to index 1 and in array A, element at index 1 is 3. So we will increment the frequency at index 3 by 1 and now the frequency becomes 2. Since the frequency now became 2, that means we have found 3 as a common element between A and B. So we will increment the common element count by 1. But we are not yet done for index 1. In B at index 1, we have element 1. So we will increment the frequency at index 1 by 1. So it becomes 2. So that means we found 1 as a common element as well. So we increment the common element count to 2. And now since we have processed both the arrays, we will set common element count, that is 2, at index 1. Now we come to index 2 and in array for index 2 element is 2. So we increment the frequency at index 2 to 1. And for B also at index 2 element is 2. So we increment the frequency at index 1 to 2. So that means we have found one more common element. So we will increment the common element count to 3. And now since we are done with both the arrays for index 2, we will set 3 as our answer. And finally we come at last index and in A we see element 4. So we increment the frequency at index 4 to 1. And then in B also we see 4. So we increment the frequency at index 4 to 2. And now the common count becomes 4. And now for index 3, we are done with both the elements in A and B. So we will set 4 as our answer for index 3. And in the end, we will return the array 0, 2, 3, 4 as our answer. Now let's jump into the code part. First, let's get the length of the input arrays A and B and store it in n. Now we can create a frequency array of size n plus 1 to keep track of frequencies of elements. And since the elements are in the range 1 to n and arrays are 0 indexed, we will create a frequency array of size n plus 1. Let's also create answer array to store the prefix common counts at each index. Let's also initialize the counter common to keep track of number of common elements. And now we will loop through each index from 0 to n minus 1 in the arrays A and B and increment the frequency of ith element in A by 1 using this prefix increment operator. And if the frequency becomes 2, it means this element is a common element. So we will increment the common counter by 1. We will repeat the same process for ith element in array B. And once we are done with both the arrays for index I, we will set the current common count in the result array at index I. And once we are done with all the elements, we will return our answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is the length of the arrays, since we are iterating through the arrays only once. And in terms of space complexity, the auxiliary space complexity will be O of n for storing the frequency of the elements in frequency array. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.